Okay, this is Duncan Foley, and we're moving on from the previous week's tutorial on defining the cell. We've got the table, the bump tray and the gripper in position, and now we're going to start doing our own application with a bit of VAL3 programming inside. Okay, so we've got a cell. We're in the Cell Explorer window, and we're going to define a new application. So click on the controller, right click, new application, and we're going to call this input output. Say OK. You can see that we've now got the application here. Let's go to the geometry tab. Got the input output again here. We've got the world coordinate system, and we can put in positions of the robot in there as p-pick1, p-pick2, etc. We can also create p-points within the programming code. We'll do it both ways, and it's whichever best suits yourself. So with the input in the geometry, select the world, right click and add new data. We're going to call this p-pick1. Notice that the only available types of data within the input world is a frame, point rs and a point rx. And we're going to do a point rx. We've given it a name. It is an array, which basically means we can have brackets 1, 2, 3, 4, as many as we want. Look, coordinate system, but our arrays are size 1. We will look at an example where the p-pick has a larger size. I think it's 19 later on in another example. So you can see now in the world we've got a new point coordinate system, and it's called p-pick1, and it's got an array of 0, which basically means it's got one value, an x, y, z, or x or y, and rz, currently set at zeros. Let's do that again. So world, right click, add new data. So let's do another one. I'm going to call that p-pick2. You'll find very quickly that selecting a small p automatically presumes it's going to be a point, and it helps when we programming and stuff. So we've got another point, and then our third one, px, p-pick3. There we go. Now let's go to our flange, do add, new data. The only thing a flange can have, which is, remember, it's right at the end of the robot, we're trying to define the tool. So it's coming up with a name T-tool. And let's accept that. There we go. So we've got a T-tool. We double click on it, we can see that it's currently set at 0. So what we need to do is go to the tool, the handler, right click, copy the data Go back to the tool, right click and paste it in there, and this is the offset value. It's going to work using the valve 1. It's going to take 0.1 seconds. So what that's done is now define the distance from the end of the flange to the tool center point at the end of the gripper. And you'll have to do this every time you create a new application. Okay, so if you select the base of the robot, right click and go to joint mode. Just rotate the robot so its gripper is just over the top of the bump tray. No. Just going to look at the side views just see if it's okay. Okay, that's reasonably okay. It doesn't really matter for today's example. Just as always, it's roughly over the top of the bump tray. Right. Let's go to the Cell Explorer and expand. Remember, we're working in the input output, not the robot cell. Expand that. What we've got is 2 places for some programming to go. We can, and you should consider adding different areas to put programming in between the start and end. The start is something that would automatically happen when you switch the robot on if it was in automatic mode, and it would sort of wake up, ensure all the materials are in position and stuff, and the stop would be the last thing after the shift's finished, and it sort of puts it in a sort of sleep position and stuff. But because our programs for that we're going to do are going to be very small, I'm going to put all the program inside the start window. So I'm going to double click in there, and this is our VAL3 area where we can program. Okay, so what I've done here is I've gone to the Word document that accompanies this tutorial, and I've copied and pasted the program what we're going to run today. We've obviously got the beginning of the program and the end of the program. Reset motion, it sort of clears everything that's already been running, previous stuff, and allows us to start from scratch. Then what we've got is something called a move joint. So it moves the joints to a new location called JStart. If you remember, we have defined some locations, PPIC 1, 2 and 3. We haven't defined JStart. So we're going to have to do that. So we're going to move to JStart, but we need to take into account the position of the length of the gripper. And we've defined that in T-Tool, and we're going to obviously move it to a particular speed. We're going to take the default setting of mFast, and again we haven't defined that in our data area because we have a motion descriptor, but we haven't defined mFast yet. So it's going to move to a JStart position, which is normally a safe position. Then it's going to move down and it's going to approach a point, and we're going to call that PPIC 1. Approach is a really good method of programming your pick and place movements. It allows you to go near a point defined by a variable called T-shift2. What we're going to do is going to say T-shift2 is minus 50 in Z, which basically means go to PPIC 1 but 50 millimeters higher up. So don't go straight to PPIC 1, go to just above 50 millimeters above it, and then you've got the T tool and do it slowly. Then you're going to move in a straight line and move L, a linear movement, to P-pick 1. So you're going to go to just above P-pick 1, 50 millimeters above, then you're going to go straight down to P-pick 1. What we could have done is define the approach position as a different pick, but if P-pick 1 moves, then we'd have to redefine both of them. Because we're using an offset value, this minus 50, we only have to teach it one position. So it's gone down to P-pick 1. Wait and move, I tend to put that in quite a lot. What this does is make sure that the robot gets to this P-pick 1 position before it does anything else. If you run the program at full speed, it might go to P-pick 1 or set off to move towards P-pick 1, then drop to the next line down, and if it doesn't have a wait end move, it might start moving to P-pick 2 before it's got to P-pick 1. So you say wait until you get to P-pick 1 before you do anything else, and then it moves to P-pick 2, waits until it gets to P-pick 2 before it does anything else, and then finishes. So it's not a particularly stunning program, but it does introduce quite a lot of things for us. So what we need to do is, I'm in the VAL3 tab, and we've got this syntax check. Just going to click on there, and we've clearly got some issues. So JStart, it's an invalid name. It doesn't know what that is. So the way we define that is you click on the word JStart, right click, add new data. Because it's a joint, a J, it's got J at the beginning, we've decided to use J. It's presuming you need a joint RX, which we do. And you say OK. So we can actually see now in our data, probably better in geometry. There we go. JStart, and it's there. Don't forget, robot cell is something we did in the previous video. So we've defined JStart, so hopefully if I run my syntax now, I won't have 4 errors. Oh, I do, because it's gone further down and found more. The next thing it said is it doesn't know what mfast is. Well, we know mfast is a motion descriptor. Just go to data. Got a motion descriptor here, but we haven't got one called mfast. So we right click, add new data. Because it starts with the letter M, it presumes you mean a motion descriptor, and yes we do. So if you click on there, we've now got a motion descriptor. Let's do a checklist, check syntax error again now. So this T-shift2, this is this offset value. So right click, add new data, and it thinks, because it begins with T, it's a tool, but there's 2 that start with T, and we want this translation option. And there it is in the data. If we expand that, we know we've got a variable called T-shift2. Just double click on it. Now I know that I want that to be minus 50. So go to position P-pick 1, minus 50 in Z. So I've only put in Z. This is a really powerful feature. Okay, numbers slowly reducing, so we've got another motion descriptor, so move slowly. We've got an M fast, we haven't got an M slow, so right click, add new data. It's a motion descriptor, so it's appeared in here. Check again. Next one down. Where are we? P-pick 2. Okay, what it's saying here is when I created P-pick 2 earlier, I must have not made it the correct format. You can actually see in the world it's got a robot icon, whereas it's got a world icon there. So I'm going to right click on there and delete it, and then redefining it here and it's a point RX. I must have picked a different one, so it's now happier there. And M slow, we've done M slow there, but you can see that this M slow has got a lowercase s, so it needs to be uppercase, so it is case sensitive. And there we go, with no errors. Our program is not going to do much because J star, PPIC 1 and PPIC 2 are currently all 0, so it's not going to go anywhere. So what we need to do now is teach the robot where PPIC 1, 2 and J star is. So this position here, I think that's kind of okay for PPIC 2. Then I'll move it to the side for PPIC 1, and I'll move it a little bit higher up for the J star. So with PPIC 2 selected, I'm going to right click, and you get the here. So that will tell the software that is where I want PPIC 2 to be. Just going to rotate the base just a bit around here. Really doesn't matter for this example. Go to PPIC 1, click on PPIC 1, right click and say here. And then I'm just going to lift it a bit out of the way. Go and find my J start, right click and say here. Okay, so we've defined all our variables. We've taught the program taught the robot where our 3 points are. Now what we'd like to do is simulate this little movement. So go to our 3D view. I don't need this area again. Just gonna zoom up a little. What we need to do now is bring up the robot emulator. So if I go to geometry, go to the controller, right click, show emulator. Grayed out is restart emulator. When you show the emulator, I'm going to say out loud that, and that shouldn't happen at university. You should get the big emulator. If you haven't got the big emulator, what you're going to have to do is save your work, come back out here, go to settings, emulator, and tick box this. Then what you'll have to do is come back and open your original, reopen this. But I have my emulator. If you've had a chance to use the robot, this screen should be familiar with you. So if we can click on this window, you notice there's an icon at the bottom that represents this emulator. If I click on this perspective view, the emulator disappears. This is where it would be nice to have a double screen. So with the application manager running, press return again. I have a USB in my laptop, but I can find that the disk is there. Expand the disk by using the right button on the keyboard. I've got two applications. I want the input output, so I want to say OK. If I actually look in there, you can see the global variables, the flange, the tool I've already defined, world coordinates, PPIC 1, 2, 3, the joint, that J start, my motion descriptors, etc, etc. So it's all there. The program is there as well. If I wanted to press return, and there's my program. Okay, just go back to the menu, boot of that. Okay. I'm going to, currently it's got this hand icon button above. If you press this circle next to it, it should toggle to the next one along. Switch on the sort of virtual power to the robot. currently running at 10%. You definitely want to be running at 10% when you run the application on the robot. For today, I'm just going to move it up to 50%. I need to go to the simulation. I'm not going to click on the show trace because it's not moving very far. I'm going to click on simulation. I'm going to run the program. It's saying, do you really want to run input output, and say OK, and then move. You have to keep the left hand mouse button down, so it's gone to J start, go to PPIC 1 and 2. So it's finished. Not a particularly stunning program, but it works. I'm going to stop the application. No application is running because it actually got to the end of the program. Power off. And well, if you're ever going to go back and change the program, you need to switch this emulator off, or when you go to right click on the controller, restart the emulator. You will get, if you do what I did, you get an error message because I've not switched the simulator off. So I'm going to go back to my program and go back to my Word document and sort of bring in the next next program. So again, reset, move to J start with the tool settings, length of the tool to the tool center point, at a speed of motion descriptor and fast. Go to an approach point, which is defined by the -50 in the variable shift 2. There's the tool. So you go into just above PPIC 1, then you're going to PPIC 2, then you've got to PPIC 3. The thing what we haven't done is we haven't defined PPIC 3. So there's PPIC 3. Click on the base again, right click, go to joint mode, just move maybe there, right click, and it's here. We do have the option to right click and here with configuration, because currently your robot, if you can imagine, is working with a right shoulder. You can spin it all the way around and have it in a left shoulder mode. If this is important to you, then make sure you keep with the configuration that the robot is. But I'm okay with that now. Go back to our program, check the syntax. Because we'd already defined all these previously in the input-output application, everything's been found okay. All we've done is just added an extra move. So let's just close this window, control, right click, and show emulator. Right, so like I just said, if the emulator is still running, either restart it or show emulator. What you want to make sure is the program that you've just edited is the one that the emulator is using. Okay, so get the VAL, press return, right hand key, press return again, go back to the simulation tab and switch the simulation on, go back to the emulator. We're still on this the feature right at the end, so we can run and hold down the move button, put the power on, run the program. Do you want to run the input output application? Yes we do, so okay. So move, there we go, and it's gone through all the program and finished. Okay, switch the power off. If I press stop, the application is finished, so there'll be no application running. Power down, say okay to that. What we could do if we wanted, we could run the emulator with the record button on, but because I'm screen capturing and things like that, it's not really going to work for me. But you can select the Microsoft Video 1, set a location, press OK, and then load up your emulator and run that same program, and you'll get a nice little movie that'll demonstrate your program running. Okay, that's the end of this tutorial. Thanks a lot.